Hi everyone. Here, when designing the checkers learning problem, how to choose the target function. Actually, the target function is used to determine what is the type of knowledge exactly to be learned during its training experience to make the performance system to works better. In checkers game, among set of all possible legal moves, we have to choose any one of the legal move. Here, the diagonal move with the single step at a time is called legal move. That is the target move in this checkers game. So here the set of legal moves are given for the checkers game. Move only in forward direction. So in this direction, and also single step move per chance. Move only in the diagonal direction and jump over the coin when opponent is killed. Suppose opponent is available here, then this coin can jump over this, right, to kill the coin. In the learning system design, we will use some of the notations to choose the target function. Here the target function is denoted with v of b, b in the sense board state, that is mentioned here, and the capital B in the sense set of legal moves. So each move is called B. So B1, B2, B3, etc. So B is having set of legal moves. Here, during the direct experience, the learning system needs only to learn how to choose the best move among the set of large number of movements. The learning system is used to find a target function, either that move will help to choose the best among all the alternatives. Let's consider the function choose move, which is denoted with notation choose move is the function. Here the from the set of board states we are moving into the next state, that is called legal move. The legal move will be any one of the movement. So here the input will be any one of the state board state, and output will be the next state, that is with using the legal movement. In indirect experience, which is difficult to learn this such kind of function, so instead of this function in indirect experience, the learning system is using real score to every board state. So the real score function is defined as this is the target function v, then board state input is the board state. When it is reaching to the next state, it is using the real score. Real score is denoted with the real number r. Here the real score is assigned to each and every board state. Whichever board state is having the highest score, then that board state will be assumed as a or considered as a better board state. If the system is successfully learned such a target function v, then it can easily use this particular move to considered as a best move to move into the next board state. For example, here we have given the target function value v of b for an arbitrary board state. Suppose this is the board state we are considering. For this we are giving the variable small b. From this we are assuming that if the board state is the final state, right, if the board state is the final board state, then if it you assume the game is won, right. If the game is won when it is the final state, then we are assigning the value v of b equal to 100. The positive value will be assigned to this v of b, that is the target function of b equal to plus 100. And if the b is final board state, suppose our this state is final board state, but you lost the game. If it is the case, you will assign with the target function value is minus 100. And the third choice is if the b is the final board state, but the game is drawn with the opponent player, then you can assign the target function value is 0. But fourth condition is if b is not a final state, in the game, then we will move into the next state. So this is the approximate target function. It should be calculated by using the learning system, right, to move into the next state. Suppose if it is the not final state, then you have to move into the next state, then again next state. So like this, if it is the case, then v of b equal to v of b dash. B dash in the sense here the target function which is calculated by our learning system. The learning system is calculating the next step, next target, next function, next step by making legal move until end of the game. So here if you are not reaches the final state in the board, then you have to repeatedly move the coin until reaching the final state. So it is called recursive definition, which is not efficiently computable when you are designing the checkers game in this recursive definition. So it is called non-operational definition. Whenever we are designing the learning system, if it is not efficiently computable, then it is called non-operational definition. So this picture indicates how we are assigning the real score value, real number, right? Real number is called real score, how we are assigning for different choices. Now the goal of learning system is to discover the operational description. That means it can be used by checkers playing program to evaluate the each and every state in the board, and also select the moves within the realistic time bound. For making each and every movement from one state to another state within the time bound, we should make a move, right? Then only we can win the game, right? So that should be a best move. It may be very difficult in general to learn such an operational form, that is to make the movement within the time bound is somewhat difficult. So we expect learning algorithms to acquire only some approximation target function v cap. That means suppose if it is the value 100, target function value is given in the data set, but we cannot get accurate value 100. We may get 101 or 99, close to that value. So that's what approximate value can be find out by using the uh, approximate learning algorithm. So now we have to choose the representation of the target function in better manner. Thanks for watching.